Hello everyone, this is Math.io with you today. I hope you had a great day so far. Today we are going to be integrating this function right here, 1 over e to the x plus 1 with respect to x. We are going to calculate the indefinite integral of this function. So yeah, we are going to do it using two different methods. One without using u substitution, and the other using u substitution. So yeah, let's begin. First, we are going to rewrite this integral right here, 1 over e to the x plus 1, and here we are going to write a 0 plus. Doesn't really matter. Okay, now we are just going to re-express the 0 in a different format. We are going to rewrite it as e to the x, negative e to the x plus e to the x plus 1. E to the x plus negative e to the x, or e to the x minus e to the x, is basically 0. So we haven't broken any math rules here, so we are good so far. With respect to x. So we are going to break this fraction into two parts. The parts that we are gonna need today, that we are going to be breaking the function into, are this part and this part. So it's going to be the integral of e to the x plus 1. We are going to start with this part here, over e to the x plus 1. And then we are gonna add the other parts. So it's gonna be basically e to the x over e to the x plus 1 with respect to x. So by integration rules, we know that we can break the integral into two different integrals, which is what we are going to do in the next step. We are going to rewrite this as the integral of e to the x plus 1 over e to the x plus 1 with respect to x. This is our first integral. Then we are going to write the second integral as e to the x over e to the x plus 1 with respect to x. Now we can just see that these expressions are the same. Meaning we can just come here with the other pen and cancel them out. And here we can do another observation. We know that the derivative of e to the x is e to the x, and the derivative of a constant is 0. Here we have e to the x over e to the x plus 1. If the derivative of this is 0, which is here we have a plus 0 that we don't really need to write. So this, the top part, the denominator, the denominator of the fraction is the derivative of the bottom part of the numerator. So we can basically write this as the derivative of this part over this part. So we are going to rewrite this as the integral. Having cancelled out this and this integral becomes the integral of 1 with respect to x minus this other part, which is, as we have just said, the derivative of this dx of e to the x plus 1 over e to the x plus 1. With respect to x. So, we know we have a property that says ln of a certain function, let's call it u. The derivative of this with respect to x or any other variable, depends on what variable does the u take is equal to the derivative of the inside function over the inside function. So it's basically d du d dx of u over u. This is the derivative of the ln of a function. The derivative of the function over the function itself, which is what we have here. Meaning that this is the derivative of the natural log of e to the x plus 1. So we can just do that in the next step. Yep, and let's rewrite it. This gives us that this is equal to the integral of... First, we can just calculate this. We know that the integral of a constant is the constant times the variable. 1 times x is x. Now we are going to subtract this integral here, minus the integral. We have just said that this is the derivative of the natural log of the inside function here. So it's the integral of d dx of ln of e to the x plus 1 with respect to x. So now we can cancel the dx's out. The differentiation cancels out with the sum, leaving us with x minus ln of e to the x plus 1. And because the integral is indefinite, meaning that this function should be a function that if we differentiate, it gives us this back. If we add any constant here, it wouldn't matter, because when we differentiate a function, any constant that is added goes out. So we can just add a certain constant, let's call c, with c a real integer. Okay. We can rewrite this as plus ln of 1 over e to the x plus 1 if we want to use the original function, but this looks way better, so we are going to keep it this way. Okay, so this is our results using the first method. Now we are going to go to the second method using u substitution, but first let us clear the board. And we are back, and we are going to start integrating this function, but with the second method that we said we are going to use, u substitution. So first we have to set our u substitution. What can we choose our new variable to be? It can either be e to the x or e to the x plus 1. Just because I want to, I'm going to pick e to the x plus 1, the whole function in the bottom. So what are we going to do here? We are going to let u equal e to the x plus 1. This basically means we are going to need this later, so we can do it now. This means that e to the x, let's subtract minus 1 on both sides, meaning that e to the x is equal to u minus 1. There we go. So what we can do here, differentiating the top line, both sides. So we are going to get du dx is equal to the derivative of this, which is easy to evaluate. This implies that du dx is equal to d dx, the derivative of e to the x plus 1. So, what's the derivative of e to the x plus 1? First, the derivative of e to the x is e to the x, doesn't change. And the derivative of 1 is 0, because any constant, when you differentiate it, is 0. So we get that. We get that du dx is equal to e to the x. We need dx in order to replace it here, the value of dx, using u. So we are going to rewrite this as, we can multiply by dx on both sides and divide by e to the x on both sides, giving us that dx is equal to 1 over e to the x du. E to the x, we have just said its value, which is u minus 1. So we are going to replace the value of e to the x in here so that we get a value of dx in terms of u. So dx equals 1 over u minus 1 du. Just going to replace this with its new value, which is u, and we are going to replace dx with its new value, which is 1 over u minus 1 du. So this integral, let's call it I. The integral is equal to the indefinite integral of 1 over u dx, which is 1 over u minus 1 du, times 1 over u minus 1 du. This is equal to, first, let's jump this in one fraction, which is 1 over u times u minus 1 du. Then, like we did in the beginning, it's a similar step. We are just going to rewrite to add a 0 here. Why are we going to add a 0? So that we write it as u minus u. A number not minus itself is 0. So we can just rewrite this as u minus u plus 1 over u times u minus 1 with respect to u. Now what we are going to do is break this fraction into two parts. We are going to rewrite it as the integral of u over u times u minus 1 minus the integral of u minus 1 all over u times u minus 1. Because negative 1 times u is negative u times negative 1 is positive 1. So no issues here. All with respect to u. Here we can see that u and u repeat here, cancel them out. U minus 1 and u minus 1 repeat, you can just cancel them out, leaving us with two fractions. So we have the integral of 1 over u minus 1 minus the integral of 1 over u with respect to u. Now we are going to break this apart into two integrals. So we are going to get the integral of 1 over u minus 1 with respect to u minus the integral of 1 over u with respect to u. So these are really easy integrals. So the integral of this here is just the natural log of the absolute value, because we don't know if this is going to be negative or positive yet. Neither do we do for this. So we are going to add absolute values so that we don't go into complex numbers. We need to keep the inside of the natural log positive. So here we have natural log of u minus 1 minus the natural log of u. We can add our constant here, but let's just keep it till the end so it doesn't bother us that much. So we know that u is e to the x plus 1. You can just substitute everything back. So we get that this is equal to the natural log of the absolute value of e to the x plus 1 minus 1 minus the natural log of e to the x plus 1. Okay, now absolute value we set. So, first, we have 1 minus 1 here, cancel them out. So let's first note a few things. E to the x, we know that for any real number, it's positive. If x is a real number, e to the x is positive. So, we don't really need these absolute values. Let's get rid of them in the next step. This is the natural log of e to the x minus the natural log, and just rewrite it as this. Now we know that the natural log and the exponential function are reciprocals, so we can just cancel them out, leaving us with x minus the natural log of e to the x plus 1 of e to the x plus 1. And the same thing that we did in the beginning, we can just add another constant because it wouldn't change anything. And this constant can be any real number. And voila, we got the same result as the beginning. You can box it around. And yes, this is the integral using U substitution. So I hope that you learned something new today, and see you next time. Goodbye.